Welcome to this video where I show how to use a changing guide curve within HEC-ResSim. And this video comes from a question that I got on the YouTube channel that asked, if I have a guide curve or a type of conservation that changes based on the current conditions in the basin, how would I actually go about handling that? So I have a couple of potential solutions that I wanted to discuss in this video. And oftentimes you'll run into this, if you have wet, normal, or dry conditions within the basin, maybe you are using a different rating curve for that. So I wanted to show you the first option. By the way, this is a very simple model that you've probably seen before if you've watched other videos. It's just a very simple schematic with one reservoir. So we're going to go look at the properties of this reservoir. And the first thing I do is I just create an operation set. You do that by going to Operations, New, and you create an operation set. And we're going to look at the conservation zone. And the conservation zone is just 75 for the entire year. So I made this operation set constant of 75. So let's say that that's one of your guide curves that you would use under a certain condition. Now for the next guide curve, I put in a V-shaped guide curve. So, and obviously this is unrealistic. I can't imagine this being used, but let's say that you would use this under certain conditions. Here you can see you can make another operation set and have a V-shaped guide curve. Now, you're probably going to want to use something like this. This is actually a good solution for real-time reservoir operations. So if you're just looking out maybe a few days or a few weeks and you know what guide curve that you're using at that time, then you can just choose that operation set and use that to solve for your operations for the next couple of weeks or whatever time frame that you're using. But if you're looking at doing a study where this could change from one guide curve to another, you may want to consider doing an external time series, which means that you would actually solve this outside of HEC-ResSim, and create your guide curve and then just import that guide curve into HEC-ResSim. And so then the way that you would do that is, again, you just create another operation set, and I call this using external time series. And then if we look at the conservation zone, this is a function of, by the way, if you hit the define for a function of, you can see that it is a function of an external variable, and we told it that we're defining the zone with a time series. You have a couple other options. Obviously, we use date. You can use date and time if you need to be more specific, if you need to put a time in there. You can make it a model variable. I'm not really sure that would work for the case where you have a different curve for dry, normal, and wet. And again, I'm not sure that a state variable would work. You could probably put in parameters into a state variable and then feed the elevation out to the HEC-ResSim rule set or to the HEC-ResSim operation set. I'm a little bit concerned, though, that you might see this abrupt change in the level of the guide curve, as the conditions change, as it hits that border, but that causes the change. You might see this abrupt difference in the guide curve, and I'm not really sure that solution would work really well. So what I would prefer to use is an external variable where I actually do solve this on the outside. Okay, so if we go ahead and apply that, now obviously when we're doing this, we made the operation sets, but we need to make alternatives, so that way the alternatives can then be used within a specific simulation. And I go through that in other videos, so I won't talk about the simulations, but I will show the development of the alternative. So here I did make one alternative, and I called it constant 75, and what I wanted to show is the operation. So I'm using the operation set constant of 75, and also I'm using the time series, and I have time series for the main inflow and the tributary inflow. And so we want to make a new alternative, and we want to call it V-shape. And again, you can put in all your parameters, and we want to develop an operation set called V-shape. We'd have to put our look-back data in. And time series is going to be basically the same, so we're going to select our DSS path, and we want to make sure that we have that highlighted, and I have to move these windows around, but we're going to set path name for that one. We're going to highlight this one and then do set path name, and looks like that we're good with our main inflow and our tributary inflow. So that's all we had to put in for time series there. And again, that's the only time series we had to put in for this constant of 75 and for the V-shape. Okay, so we're going to save that. And now I need to make one more alternative to define the time series. So this is where we use a time series to define the top of conservation zone. So again, I'll put the same information in, but for this case, for the operation set, I'm going to use the operation set that we called using external time series. I can put in the same look back data. And now you see when we open up time series, we have both the main inflow and the tributary inflow, but I also have the main stem reservoir conservation zone, which I went out and I put into a time series. And I do have a video that shows how to make the time series, and we can go ahead and we can plot this, and you can see that let's say that you went in the first year you were using this constant 75, but then the conditions changed and you had to use the V-shape in the second year. So that's the external time series that it's using for this case. And again, this is a very simple example of how to do this. So then we can put our time series data in. So actually, for our zone elevation, I have that one open already. So I'm going to, I think I need to close that. Okay, there we go. I had lost that window. So we'll set the path name for our flow, and then set the path name for our flow, and then what I need to do is I need to then go in and change this. So I need to open up my zone elevation.dss. So I'm saving that in a different DSS file. That's why I have to go and open it up in a different file, and I need to change that and set path name. So that was the difference. Again, I had to put my two flows in for the main flow and the tributary, but now also I have to define that external time series that I'm using for the top of conservation. And then I can go ahead and save that, and then I have all three alternatives now. So if I look at the alternatives, I have the constant 75, the V-shape, and the time series. And I can use these two typically for the real-time operations and time series if I'm actually doing a study. Now, one of the things that may be a little bit problematic with this technique is that if you're using time series, if your guide curves are determined by external variables that are not dependent on what HEC-ResSim is doing, then that would probably work fine. However, if the guide curve starts to become dependent on something that you are getting out of HEC-ResSim, it may turn into somewhat of an iterative process that you have to do with your external program, where maybe you have to run the model several times as you're getting results, and maybe tweak the guide curve that you're using in your external time series. So again, it could be, you know, somewhat of an iterative process that might be a little bit more time consuming, but you know, that is a way to handle that changing guide curve that's occurring over time, to where, you know, you can't just put in a constant guide curve into the operation set. So hopefully you found this video helpful. If you want to know when more videos are coming out, feel free to subscribe to the channel, and thanks for watching this one.